Good morning, children. Today we are going to see the physical properties of non-metals. We have already studied the physical properties of metals, right? Hope you have studied the whole thing. After studying all the properties, recap it once and then we will go to physical properties of non-metals. Okay? Some examples I will tell now. For metals, if I ask you some examples, you will be able to give because you already studied iron, copper, gold, silver and all. Okay. Now in non-metals, if you see, we will see some examples. What is C? Carbon, nitrogen, oxygen, fluorine. What is this I? Iodine, chlorine, bromine, carbon, then phosphorus, sulfur. Okay. What is the symbol for chlorine? Okay. Now allotropy. What do you mean by allotropy? Allotropy is a property of non-metal. Okay. All the non-metals or some non-metals will show allotropic forms. You want to know what is allotropy? No? See the definition. The property of an element to exist in more than one form. Metals will not show allotropy, but non-metals will show allotropy. In carbon chapter, you will be studying that. There are three forms. See here? In carbon, there are three forms. Three allotropes are there. They are diamond, graphite and fullerene. Okay? Diamond, graphite and fullerene. So, carbon chapter we will be studying about what is allotrope. Now, we will study only the definition. That is the property of an element to exist in more than one form. In more than one form, it may be 3, it may be 5. See, carbon I said 3 forms. But phosphorus, if you see, there are 5 forms of phosphorus. For example, white phosphorus, red phosphorus, then black phosphorus, violet phosphorus and all. There are many. Okay. And sulfur also there are 3 forms. This is a homework for you. Find out the 3 forms of sulfur. Allotropic forms. Okay. So with this introduction, we will study the physical properties. You have already studied about non-metals. Yesterday when I was asking, you explained it clearly that non-metals will gain electrons or lose electrons. Yes, good. They will gain electrons. For example, we have studied chlorine, right? Okay. Now, 2 important things. Allotropy means it's the property of an element to exist in more than one form. This word is important. In more than one form is called as allotrope. Same way, examples. Carbon, we will have 3 forms. This you should study because this you are going to study this year. Diamond, graphite and fullerene. In phosphorus there are 5 forms and in sulfur there are 3 forms. Okay, now we have studied about the physical properties of metals. Same way, it is just the opposite of the properties. If you see, metals will have the property, non-metals will not. We will check once. See, metallic luster. I have told you the definition. It will be shining appearance. No, metals will have that luster. In case if it is not there, if you rub with what? Sandpaper, you will get that luster I said. But here, what happens? Luster will not be there. But exception is there. See, iodine. Iodine is an exception. It's a non-metal, but it will be shiny. This is an exception. Hardness, you have studied the second property. There it will be very hard. For example, iron you have studied. Here, it is not hard. You can break it easily, brittle. Melting point and boiling point, if you see there it is high melting point and high boiling point. Here it is low melting point, low boiling point. Malleability and ductility, of course, that we have studied it in that one. Malleable, it is ductile. Here, no, it is not malleable, it is not ductile. Electrical and thermal conductivity. What do you mean by electrical conductivity? Yes. Electrical conductivity you have studied. Here is a bad conductor. It will not conduct electricity because their free electrons will be there, right? Here no free electrons, so they will not conduct electricity. But here also some exceptions. See, graphite is an exception. You have experienced this, I think, with graphite while doing that experiment. Graphite, when you keep there, no, it will conduct electricity. So this is an exception. Density, if you see, in metals, the density is high. Here it is low. Tensile strength, Yesterday you explained it clearly that it can be easily broken. Their metals it can't be. Here it can be easily broken. So notice that it will make a ringing sound when you hit with the hard object. Here it will not make any sound. Okay. So these are the properties and it's just opposite to that of the properties of metals. This is the first part. Now the second part is we are going to study about the activity series. What do you mean by activity series? The definition: metals are arranged in the order of decreasing reactivity in a series. We are going to arrange all the metals in series, and what are the important points there? See, if the metals are higher in the series, higher in the series, the tendency to form ions. Okay, ions will be formed if it is in the top. The next one, little lesser, like that it comes. The more reactive metals are placed at the top, okay, in the series if you are arranging the metals, the more reactive metals will be placed at the top, which can displace the other, which is below, no, it can displace the other, that you will be studying with the help of chemical equations, how the displacement takes place, okay. So the top metal will displace the metal which is placed below that. Okay, most reactive metals are placed at the top, which can displace the others in a solution. Just like that they can't. In a solution form, if you keep, no, they can displace it. Okay. The next thing what we are going to see is what is that activity series. Okay.